And now we will take another problem of finding the missing readings. This is a pretty simple problem. The following data is of a closed traverse. Compute the missing quantities. Over here we have one line of which we could not measure the length. We could not get the angle also. Okay, it was quite difficult to measure the length as well as the angle for this particular line. The rest of the lines have been done with great accuracy. That is what is our assumption. The line AB length is not known. The WCB, the whole circle bearing, is not known. BC, the length is 750 meters. The whole circle bearing is 160 degrees. CD, 700 meters. The whole circle bearing is 250 degrees. DA, 810 meters. The whole circle bearing is 350 degrees. Please note, as mentioned earlier, whenever one or more quantities are not known, we assume that there is no closing error because we cannot find any closing error in that case. So we assume that there is no closing error and we move ahead thinking that all the readings have been taken with great precision. Now in this case, the length and the theta, the angle of one particular line, is not known. So we need to know how we are proceeding to find out that particular length and that particular angle. So let's proceed. So calculate step number 1. Calculate the latitudes and departures of all the lines. This step is same as the earlier one, and it says that whatever length is unknown, put a variable for that, and similarly for the angle also put a theta over there. So for the line AB, length is taken as L, the whole circle bearing is taken as theta. So latitude is L cos theta. Latitude is L cos theta as per the formula. Departure is L sin theta. There's nothing much to be done about it because length is not known, theta is also not known. Let us work on the next line BC. Length is 750 meters, angle is 160 degrees. Having known the length, having known the angle, latitude is L cos theta. L is the length 750 meters into cos of 160 degrees. So that way we get L cos theta as minus 704.77. So latitude is negative. It tells me that it is southing. So for BC, it is southing, which is 704.77 meters. The latitude of BC is minus 704.77. The departure is calculated as L sin theta. L, that is the length, which is 750 into sine of 160. So 750 sine of 160 gives me the answer as plus 256.52. This tells me that departure is in the east direction. So it is easting, which is 256.52. Coming to CD. CD, the length is 700. The whole circle bearing is 250 degrees. So latitude is length into cos theta. Length is 700 into cos theta, cos of 250 degrees. So 700 into cos of 250 degrees. It comes to equal to minus 239.41. This tells me that latitude is in south direction, or it is a southing of 239.41. Southing of 239.41, or the latitude of CD is minus 239.41. Coming to departure. Departure of CD is length into sine theta. So length is 700 sine of 250 degrees. 700 sine of 250 degrees gives me the departure as minus 657.78, or the departure is a westing of 657.78. It's on the west side. That's why it is negative. Coming to the line DA, the length is 810. The angle WCB, the whole circle bearing, is 350 degrees. The latitude is L cos theta. Latitude is length into cos theta. Length is 810 into cos of 350 degrees. So 810 cos of 350 degrees gives me the answer as plus 797.69 as the latitude, or it is northing, which is 797.69. Coming to departure, Departure is L sine theta. L is 810 sine of 350 degrees. So 810 sine of 350 degrees, which is equal to minus 140.66. Or the departure is on the west side, westing of 140.66. It is a westing of 140.66. So we have calculated all the latitudes, all the departures, though some have been calculated with their unknown. So that is my step number 1. Going to step number 2. Just as in the previous case, obtain the sum of latitudes as well as all the departures individually. So latitudes is L cos theta minus 704.77 minus 239.41 plus 797.69. So putting latitudes together is L cos theta minus 704.77 minus 239.41 plus 797.69. Similarly, departures L sin theta plus 256.52 minus 657.78 minus 140.66. Getting them together, L sin theta plus 256.52 minus 657.78 minus 140.66. So that's step number 2. Obtain the sum of all the latitudes, all of the departures. The sum of the latitudes as well as the departures should be equal to 0. That's my step number 3. So putting the sum of the latitudes equal to 0, I get L cos theta with all these numbers, L cos theta equal to plus 146.49. Similarly, putting the departures equal to 0, 0 equal to this full sentence over here containing the values, I have L sin theta is equal to, all these get added together, move on the other side, becomes plus 541.92. Please note, we have got L into cos theta equal to plus 146.49 as equation number 1, and L into sin theta is equal to plus 541.92 as equation number 2. Over here we have two variables, both are multiplied to one another. We have two variables, both are multiplied to one another. Let us see now what we do about this next. In step number 4, take the square of the left hand side and add up the equations. When I take the square of the left hand side and add up the equation, I get L square into bracket cos square theta plus sin square theta is equal to, right hand side becomes 541.92 the whole square plus 146.49 the whole square. Solving it, we get the value of L as 561.37 meters. Very simple, L becomes equal to 561.37 meters. Now to find theta, we simply have to divide equation number 2 by equation number 1, or equation 1 by equation 2, as the case may be. So L and L gets cancelled, sin theta upon cos theta becomes tan theta, and this value comes to 3.7. Now when tan theta is equal to 3.7, theta will be equal to tan inverse of 3.7. So tan inverse of 3.7 is 74 degrees, 68 minutes, 50 seconds. So it is very simple. In order to find out the two variables, first what we have done is we have directly taken the squares and we have added, we have taken the square root, we got the value of L, and dividing both of them together, we got this value. If we did not want to do this, please note, if we did not want to do this, we could first find this by taking L sin theta upon L cos theta. We would be getting the value of theta. Substitute that value in any of the equations, we would be getting the value of L. So in maths, any way you solve, you will be getting the same answer. You can solve it for theta first and then L, or you can solve as in this case for L first and then get the value of theta. Okay, that's the way we solve for missing readings. Thank you.